Good morning, everyone. Today um, we are discussing about classification of images by using machine learning. So I used KNN and SVM model for classification. So this is the code. So in the cell, we import all the libraries. So like NumPy. NumPy is used for numerical operations and Matplotlib and Seaborn for visualizations. TensorFlow to load datasets like FashionMNST and CIFAR, and Skitty-learn for building and evaluating ML models, so such as SVM and KNN. So in this cell, we load the FashionMNST dataset, which contains grayscale images of clothing items. It separates the data into training and test sets, and then displays the first image in the training set. This helps verify that the data has been loaded correctly. So here we normalize the pixel values by dividing 255 so that they will fall into range 0 to 1. Then we flatten the 20 or 20 images into 1D arrays of 784 features. This is necessary because both SVM and Canon models require 1D feature vectors as input. So here we initialize an SVM classifier with the RBF kernel, which is good for capturing nonlinear relationships. Then we fit the model using the flattened fashion matched training data. After training the SVM model, we use it to predict labels for the test data. Then we call the model accuracy and print a detailed classification report, which includes like precision, recall, and F1 scores for each classes. So the cell generate a confusion matrix to visualize how well the SVM model performed. The heat map shows correct predictions on the diagonal and error off diagonal, helping us understand which classes were confused. Now we train KNN classifier use the same training dataset. KNN is a simple algorithm that assigns a label based on majority classes among its k nearest neighbors. Here the k value is set as 5, mm, as we see, and this cell evaluates the KNN model by predicting labels for the test set, calculating accuracy, and printing the classification report for detailed insights. So here we plot the confusion matrix for KNN model predictions. This helps us visualize which class the model correctly identified and where it made mistakes. So in this cell, we load the CIFAR dataset, which consists of 32 color images in 10 categories such as airplanes, cars, and birds, etc. We flatten the labeled arrays and display a simple image to verify the data. So here we pre-process the CIFAR10 image by normalizing the RGB pixel value to 0 to 1 range. Then we flatten the 3 image into 1D future vectors as required by our models. So here we initialize and train an SVM classifier on the CIFAR dataset. The model uses the RBF kernel again to learn from the higher dimensional future vectors. The cell evaluates the trained SVM model on CIFAR using accuracy and detailed classification report. It helps us understand the model performance on the small complex data sets. So here we plot the confusion matrix for the SVM model on CIFAR. This provides a visual summary of classification accuracy across all classes. So the cell initialize and train a KNN model on the CIFAR10 dataset using 5 nearest neighbors. Given CIFAR10 size and complexity, KNN may be slower or less accurate here. So we evaluate the KNN model on CIFAR using the same metrics as before, like accuracy, precision, recall, and F4. So we plot the confusion matrix for KNN model predictions on C for 10 to analyze its performance visually. So here the cell compares the evaluation metrics like accuracy, precision, recall, and F1 score for all models on both datasets. It builds an Panda data frame to summarize results. So this is final. We plot a grouped bar chart to compare model performance visually. This makes it easy to see which model performed best across different metrics and datasets. So this is the charts you can see.